Hello everyone, welcome to tech2.com, and this is how to solve section. You can share this video using this hashtag how to solve, and in this section we basically approach problems from very beginning and we understand how to solve a problem. Well, so I would like to thank Kalpish Singhal who forwarded me this question, and this is a very interesting question which is basically the combination of DBMS concepts and combinatorics. So let's get started with the question. We have two transactions here with various operations, and the question is asking that how many schedules are possible by this transactions T1 and T2, but the condition is that the schedule should be conflict serializable. Okay, so to just simplify this problem, we will start with the approach. So let's write down the transactions. So here we have two transactions T1 and T2, and what are the conditions for a schedule being conflict serializable? So we have various constraints. The first constraint is that for a transaction T1 the operations should be in a order, should be in the same order. That is, this R1A in any case should not be happening after W1A. Okay, so this R1A should always be before this W1A. Okay, so what we will do is we will label these operations to simplify. So let's label it A, this is B, this is C, and this is D. Now let's label these operations here in next transactions as 1. Let's write it 1, 2, 3 and 4. So as we know that these basic operations should be in the order, so we have one constraint which is A should be less than 1, A should be less than B, should be less than C, and C should be less than D. Okay, so this is one of the order which we have to maintain. From the second transaction we have 1 should be less than 2, should be less than 3, should be less than 4. So here less than means that this transaction 2, which is here in greater than side, should be happening after this 1. Here less than means this operation 1 is being performed before this operation 2. Okay, now there are other constraints which we have to evaluate here. The first one, we need to find out what are the conflicting schedules here, or what is the conflicting operations. So if you consider this, these are A and C different operations, different variables. So these are not the conflicting variables. Now if we go to this R2B, R2 read is being performed on B by transaction T1, whereas we have write on the same variable by transaction T2. So this pair is a conflicting pair, right? These two. Similarly, if you go for W1, so for this W1, this read and write, because we know what are the conflicting combination. This is read write, write write, and write read. Fine. Read read is not a conflicting situation. So here W1 B. Okay, so for this, both these two are conflicting operations. Fine. So here we can come to the conclusion that this operation, this whole operation, that is this one, should be happening in order. That is, no two conflicting operation or no conflicting operation can come in between these two operations. Okay, so this R2 and W1 should be in order, whereas these two operations should be in order. Now another point here, if you see, this operation will not, this will be in order in T2 transaction, and this CD will be in order. So we can conclude that this D should be greater than 1, sorry, less than 1. I mean D should be performed before this 1. Okay, so we have another constraint, which is this D should be less than 1. But we have another situation, which is this operation which we have labeled as 2 will be performed before this operation C, which we have labeled as C. Okay, R2B. So in that situation we have another constraint, which is, let's write it OR, and then this 2 should be less than C. Okay, so these are the constraint which we have to follow. Now this is totally a combinatorics problem. We have to find out various arrangement. So now let's solve this. So for this situation, when D is less than 1, we have only one possibility, that is A, B, C, D, and then the transaction 2 will start. So 1, 2, 3, 4. By following these two constraints and the first one, that is D less than 1, we have only one possibility here. D is being performed before 1. Okay, so this is one arrangement. Now this is little bit complicated, we have to understand it carefully. So when 2 is less than C, now let's assume a situation where we will not, first of all, presume that this constraint is not there. So what we will have, that we have different schedules, that is of transaction 1, 2, 3, 4. Okay, and we have these places where we can put the transaction from T1, I mean the operation from transaction T1. Okay, so basically here we have 5 types of places in which we can choose 4 with repetition. What I'm saying is, here we have 5 types of places in which we can choose 4 places for these operations, and because all the operation can go at a single place, so we will say this is a case of repetition. So in this case, as we know from the combinatorics, that the formula will be n plus r minus 1 r. Right? So if we consider this formula now, we have n equal to 5 and r equal to 4, because n equal to 5 means we have 5 types of places in which we have to choose 4, but this 4 can be chosen with repetition. Okay, so we have here C 8, 4, which is equal to 70. But in this 70, those cases are also included in which this constraint is not followed. Okay, so now we will subtract those cases in which 2 less than C is violated. Here you need to understand that what we are doing is basically, first of all, we are selecting 4 places. Okay, and then we are placing these A, B, C, D in sequence. Okay, so this sequence we are always considering. So here this 2 is the threshold, fine, and this C should be greater than 2, that is C should be performed somewhere here. Okay, but in this 70, this violating cases are also considered. So the first case we will take, that all ABCD, let's write it down, that all ABCD is before 2. So in this case we will have 2 places here, 2 places, and in these 2 places we have to choose from 2 types of places, we have to choose 4 with repetition. Okay, so here we will have n equal to 2 and r equal to 4. So it would be C n plus r minus 1 r, which will be equal to c, this is 5 4, which is ultimately equal to 5. Okay, now the second violating condition is, let's assume that this d from abcd, this d is after 2 but abc is before this 2. Okay, let's write it down. So in this case where abc are before 2, we will have four types of places. If you see here, we will have this four types of uh, from this two types of places we have to choose three. Okay, so in this case what will be the number of possible arrangement? So in this case we have c, the value of n will remain 2 and the value of r will be 3. So it will be 2 plus 3 minus 1 and 3, which is equal to 4. Okay, so this 4 is for one arrangement of d. You need to concentrate here. What I'm saying is, for these two places we have to find out that four arrangements are there, but d could be at the one possible place here. So for d we have three possible places. D can be here, here and here, right? So for one place of d we have four arrangements. Okay, so for all three places we will have 4 cross 3, which is equal to 12. Okay, so the total number of violating cases we have is 15 plus 12 plus 5, which is equal to 17. So we will have total possible arrangements is total is 70, in which we will subtract 12 plus 5, which is equal to 53. Okay, so if you remember from the first case here we got one arrangement, right? And from the second we got 53. Okay, and here this is OR, so we will add these values, that is we will have total arrangement possible equal to 53 plus 1, which is equal to 54. So 54 would be the correct answer for this question. So I hope this is clear. If you have any doubt, please ask your question in the doubt section or below this video. So I hope you understand it. Thanks for watching.